Hi guys and girls, welcome to the first tutorial of JMT that may be better defined an introductory tutorial. Indeed, we will make a brief introduction to some important assumptions that must be met to create reliable models based on QE networks, and we will analyze some important parameters that are used in the models. The topics that will be briefly analyzed are the workload, the types of stations used, the QE models, different types, the solution algorithms, the equilibrium concepts, the distributions parameter, the routing strategies parameter, and the performance indices. The workload consists of all the service requests submitted by the users. Each request can be described through several parameters like CPU time, number of I/O operations, number of pages visited, etc. It is important to identify classes or clusters of requests that having similar characteristics, so that they can be replaced in the model input of the model with the mean value of the parameters of each class identified, of each cluster. The arrival process is also another important parameter that must be characterized through the distribution of interarrival times in the source or of the service time, or etc. The station types are essentially queuing station and delay stations. Those are the most important. Queuing station is a station in which the request arrives, queue for having to be served, are served, and at the exit, and then at the exit they exit the model. Then once the service is completed. The complete time spent in the station consists of two components: wait in the queue, wait time, and service time. The sum of these two times are called the response time. Are called the response time. The delay station consists only of servers without queues. This is because you may idealize this station as having infinite number of servers. So a request arrives, have a service time and exit. The service time of a delay station is typically identified with the Z, so the response time is equals Z. The two types of QE networks are typically typically used. These open QE networks that consist of one of several sources and an infinite stream of arriving requests with a given arrival rate. And in these models, we have a population of customer and execution that can vary over time, and one or more sync. And the other type is a closed model that has a fixed number of customer in execution, and this is idealized, can be seen as a model in which when a request exits the model that having a completed execution, immediately is sent back as input into the model. So the number of requests in the model in execution are essentially constant. Yes. So
I have a question. When should I use open models and when should I use closed models?
The open model should be used each time you do not control the flow of an incoming request to the system. This happens typically when you model the request arriving from an internet connection. You have no control on the intensity of the traffic. The number of requests in the model, in this case, can grow indefinitely. This is just because if one of the stations is saturated, all the requests accumulate in the model. While if you consider the closed model, these models are suitable to study systems in which the number of users or if you want to see the number of requests in execution is constant and limited. So for example, when you model a company in which you have a number of employees fixed, constant, that can use the model, the server or the system that you are modeling. Okay, now the solution algorithms that we may adopt can be of two big families: the analytical solution algorithms and the simulation. The analytical provide exact value of performance indices, and essentially they takes less time usually than simulation time. They are also subdivided into the exact, that provide the exact value, approximate, that provide approximate values of performance indices, and asymptotic, that provide only the bounds of performance indices. Then we may have the simulation model that are solved in simulation, and let's consider that the simulator have very few restrictions, while the analytical models have several restrictions. So several restrictions are applied.
Question. In JMT, where can I select the solution algorithm that must be used?
Let me, take, if you consider the first window, JMT here, you may see if you select the JMVA, collectively they are referred to all the analytical models, solution algorithms, while SIM is referred to the simulator. So if you click on JMVA, on JMVA, you have this window that will open, and here you will find all the list of all the analytical solvers that you have for the moment in the JMT, and also of all the approximate solvers that you have in JMT. Now, if you click on SIM here on the simulator, so click on this example button, the SIM, then you have this window that will open, and this means that the model that you implement is essentially a simulator. It's solved by simulation. For example, you click New, and if you if you want to model a source and a model with just one station, you click here and you drag and drop the symbol, and this is for the sink. So here we have a very simple open model with a source and a queue station and a sink here. So we should also define the other parameters maybe a little bit later. Now let's go on. We have now to analyze the equilibrium concepts. All the models typically are studied and provide reliable values provided that the equilibrium concept is satisfied. That means that the arrival rate of requests to the arrival rate to the model equals the system throughput. This assumption is mandatory for analytical techniques and is typically satisfied also in simulation techniques, but in simulation is not mandatory. Okay. Concerning the parameters of the distribution parameter means that the service time and the interval times of course in open models, those are described through their values, mean values and other parameters, and their distribution values. The distribution can be selected in JMVA are only the exponential distribution, because the analytical solver has some restriction with other distributions mainly, while in simulation with the other tools you have several possibility to select among several distributions available, or to submit a custom distribution. It means a distribution
Question.
Yes.
How can I select the distribution of service times and inter-arrival times in JSON graph?
Let's take the JSON graph that we implemented before here. For example, you may click here on the service section of this station, Q station. So first, in this model, we should define the class. Here we add a class. So in this case, we have an open class because we have a source, and here you will see that the default is exponential inter-arrival time distribution is set, but you have an edit button through which you may select through this window all the possible distribution that JMT provides. So you have several of them, and including the replayer, that is the custom distribution, custom size distribution, or now let's go back eventually to exponential, that is default and mean value 1. Okay, and similarly also for service times, you click on the queuing station and service section. Here you have the service time distribution. By default is exponential, but again here you may select all the one that you like more. Let's select 0.9 as a mean time instead of 1, just because we have an equilibrium concept to satisfy in this case. Okay, done. Now what we may do also is to select, we have to select a performance index. For example, here you have a list of all the performance index that the model can provide to you. If you may select, you like to have a system response time, for example, that's all, then you select that, and then we may also start the simulation. Okay, the simulation start. Let's size the window, resize the window here, and so you will see the simulation is going on, and here you have the mean value of the parameter, and you have also the two extreme of the confidence intervals, because we are in simulation here, the two extreme, and this is the mean value. The blue line is the mean value, are the mean values, the behavior of the mean value, and the simulation goes on until the satisfied precision in terms of equilibrium, confidence intervals, and error is satisfied, is reached. Okay, let's close this, and then now select changes. No. Okay, now we have also the routing strategies. Those are the strategies followed by the paths followed by the request, and you may select among several possibilities in the models. Then the performance indexes that are provided, we have seen all of them, and so I think we arrive at the we have completed this first introductory tutorial. In the next one, we will start to create models together, having incremental complexity. We hope you enjoy working with JMT, so best regards and see you soon.